Okay, let's consider an application of the motion equations related to free fall motion. When an object is in free fall motion, it has a constant acceleration, which means that is a situation where we can use the motion equations. So you're hiking at Natural Bridge, you're standing on top of Natural Bridge, and you drop a small stone. You time the time it takes for it to reach the ground, 2.01 seconds, and you want to use that data to be able to calculate the height of Natural Bridge. So then drawing out a diagram first of all. Use your imagination. There's Natural Bridge. There you are standing on top of Natural Bridge. Small stone in your hand. You drop that stone and it falls down to the ground. So the specific data that we know, first of all you drop it. So that means the initial velocity will be 0. It takes a time period of 2.01 seconds to reach the ground. And it's in free fall motion because after it leaves your hands and before it strikes the ground, nothing else is acting on it besides gravity. So then the acceleration is a negative 9.8 meters per second squared. What we want to find is the height of the bridge, which is going to be equal to the displacement that the stone falls through. So with this given information, the motion equation we have enough to use is this third one. Remember, delta x and delta y both represent displacement. So then on part A, delta y is equal to vi delta t plus 1/2 a delta t squared. So then I've got delta y as my unknown. Vi is 0 times the 2.10 seconds plus 1/2 times a negative 9.8 meters per second squared times 2.01 seconds squared. So 0 times the 2.01 here is 0. So then my value is the 1/2 times the negative 9.8 times the 2.01 squared. That's going to give us a calculated d sub I calculated delta y value of negative 19.8 meters. Now, delta y goes down, height goes up. So then the height we would express as 19.8 meters. Now, in part B, calculate the speed of the rock when it reaches the ground. So our interval is the same. We just want to know what VF is down here at the end of the interval. So that means when it's finished free falling, before it strikes the ground. So then finding VF, we just need a different motion equation. Looks like we have enough to use the first one. VF is equal to VI plus A delta T. So VF is equal to 0 plus a negative 9.8 meters per second squared times 2.01 seconds. That's going to give us a final velocity of negative 19.7 meters per second, which would be 19.7 meters per second downward, stating that negative as a direction. Now onward to part C. At what time or what speed would you have to throw the rock downward for it to reach the ground in 1 second? Well, that means things have changed a little bit in part C. So if we go back to our original given information, in part C we're not dropping it anymore. So then VI isn't 0. In fact, we're throwing it. And so our unknown is that VI value. If we throw it downward, it's certainly going to take less time to reach the ground. Okay? In fact, we want the time to be 1 second. So then our time period is 1 second. After it leaves our hand and before it strikes the ground, the only thing acting on it is gravity. So we can still use negative 9.8. And our delta y is not an unknown. It's going to be the same bridge. So it's still the negative 19.8 meters that we found in part A. Now, let me give us a little more space here. we can use the same motion equation that we did up there previously. Delta y equals vi delta t plus 1/2 a delta t squared. Our delta y, negative 19.8 meters. Vi now is the unknown. Our time period is 1 second. 1/2 then times a, negative 9.8 meters per second squared, and then times 1 second squared. So doing the algebra, half of negative 9.8 is negative 4.9 times 1 squared is still negative 4.9. So we're going to add 4.9 to both sides and then divide by the 1. And that gives us a VI value of negative 14.9 meters per second. And the negative means downward. So if we throw the rock down at 14.9 meters per second, then it will reach the ground in that 1 second time period. So diagram, organize what you're given, identify when your interval changes and some of your given information changes, and plug into the motion equations. Ponder physics.